This is in preparation for classwork number 4, and talking about working with absolute value and the greatest integer function. So absolute value of x, the algebraic definition is that it's equal to x or the opposite of x, depending on whether x is positive or 0, or whether x is negative and less than 0. So here's an example, like absolute value of negative 4 is 4 because you're taking the opposite of x, opposite of negative 4. Because the negative 4 is less than 0. Okay, always write absolute value expressions in their piecewise form. Here's an example that I want you to try. Pause the video and try it yourself. So you're writing this as a piecewise function. Okay, so here's what you get. So either this absolute value of 3x minus 4 is 3x minus 4, or it's the opposite of 3x minus 4. It's equal to 3x minus 4 when 3x minus 4 is greater than or equal to 0. And that would mean x is greater than or equal to 4/3. And it's the opposite of 3x minus 4 when 3x minus 4 is less than 0. And that means x is less than 4/3. So once you simplify, you're getting either f is 5x minus 1 or it's 7 minus x. And the definition changes at x equals 4/3. Pause the video and graph. Okay, so sketching the graph, it looks like this. It's a V, but both branches here are in equal opposite slopes. The slope over here is 5, and the slope over here is -1, and the definition of the function changes at x equals 4/3. So notice the limit as x approaches 4/3 from the left is 5 2/3. If I look at the limit as x approaches 4/3 from the left, I'd be looking at this definition because x is less than 4/3 if x is approaching from the left. And I could plug in 4/3 here to get 5 2/3. If x is approaching 4/3 from the right, then I'm going to look over here and I still get 5 2/3. Okay, try another example. So for this one, I want you to pause the video and sketch the graph of that. Pause. Okay, so as a piecewise function, this is what it looks like, and this is always the first step you're going to take. So either this expression is going to equal 1 or -1 when x is not equal to 2. When x equals 2, you would have a hole in this, not a hole, a step, what's called a step discontinuity. We'll talk more about the different kinds of discontinuities that you can have in a graph later on, but you're going to see the step once you graph this. So when x is more than 2, this expression will equal 1, and you're going to get x minus 3 plus 1, or x minus 2. And what this expression is, when the absolute value of x minus 2 is negative, then that would mean x is less than 2, and this expression will equal -1, and you're going to graph f of x equals x minus 4. So you get slopes, both rays equal to 1, so they're parallel rays, and they look like this. So one question you could be asked is, what is the limit of this as x approaches 2 from the right or x approaches 2 from the left? As x approaches 2 from the right and the left, think about that. Pause the video. As x approaches 2 from the right, you're getting 0, and as x approaches 2 from the left, you're getting -2. There is no limit as x approaches 2 because there's not one limit as x approaches 2. Okay, what would you see if you graph f of x equals the square root of x squared? Pause the video, try it. The square root of x squared is equal to the absolute value of x. Remember, the square root of a number is always the positive value, right? So we want to make sure that we're getting a positive value. If you graph this, f of x is going to look like a v. And so that becomes really helpful when you're dealing with limit problems. Think about this limit right here and pause the video. Okay, so we're looking at this limit, and there's a little trick that I'm going to play, which is factoring out the x squared from under the root. I'm also going to factor out the x from the denominator, but that's not super necessary. It's just maybe a little bit more helpful to see what's happening. So if I factor out the x squared in the top, I get this. And if I factor out the x in the bottom, I get that. you can see that as x approaches infinity, both 5 over x squared and 3 over x are going to approach 0. And so this limit looks like this. And then the square root of x squared is absolute value of x. So replacing this limit, I get this. So now I'm going to do a little bit of thinking. Absolute value of x has two-part definition, right? But if x is approaching positive numbers, positive infinity, then I'm going to replace the absolute value of x with x because x is greater than or equal to 0. And so this limit looks like this.
Madeline.
Sylvie.
Sorry.
And so this expression then is equal to -1, the limit of that expression, and we're getting -1/2. So yeah, doing the canceling there, you're getting -1/2. So notice that I am writing vertically. I'm writing lim every time, and that's so important because these expressions, these expressions here, they're not equal to each other, but their limits are. And so make sure that you're writing lim every single time. So let's look at another example. So this is 5a in your packet. Pause the video. Hopefully you thought to write that as a piecewise function. And when you do, it looks like this. So again, replacing absolute value with x or either minus x, you're going to get 0 or 2 over x. And so now you can answer the limit question. As x approaches 0 from the negative side, then you're looking down here. And so you're looking at the limit of 2 over x as x approaches 0 from the negative side. 2 divided by -0.1, 2 divided by -0.01. You're getting closer and closer to 0 on the negative side of 0. And those numbers are getting very, very largely negative. Largely negative. And so the limit is going to -infinity. Okay, the next part of that question, also in your packet 5b, was asking you, what about the limit as x approaches 0 from the positive side? Well, go back up here. Then you're looking at x more than 0, and so you can see that the limit is going to equal 0. Okay, let's do another one of these. So this is number 8 in the packet, example number 8. Pause the video and try it. Do notice that x is approaching -infinity here, and that makes a huge difference. Okay, so that limit, again, playing the same trick. If I factor out the x squared and factor out an x from the bottom, these two expressions here are going to be going to 0. And so this limit is equal to this limit. And so this is root 5x squared here on top. Again, so that's the same as root 5 times root x squared. And root x squared is equal to absolute value of x. So that limit is equal to this limit. Now you have to do a little thinking. What will you replace the absolute value of x with? Think for a moment, pause the video. Okay, so the absolute value of x is going to get replaced with opposite of x because x is approaching very large negative numbers. And so that limit is equal to this limit. And now you can see that x's cancel and you're getting minus root 5 for the limit. Show every step, write lim every time. Don't forget the absolute value step, and write vertically. Okay, so what I want to talk to you about now is the other function that comes up a lot when we talk about continuity and limits. So it's called the greatest integer function. You were introduced to it in sophomore year, and it's defined to be the greatest integer that is less than or equal to x. Sometimes you write it as the floor function, looking like this. So you might see it like that too. The greatest integer that is less than or equal to x. I want you to take a moment and come up with these values right here. Pause the video to do that. You're finding the greatest integer that's less than or equal to 2.3, 0.5, etc. Pause the video. Okay, so the greatest integer less than or equal to 2.3, that's 2. The greatest integer less than or equal to 0.5 is 0. The greatest integer less than or equal to 1 is 1. What about this one? The greatest integer that's less than or equal to negative 0.5, that's negative 1. Negative 1 is smaller than 0, so be careful with that. The greatest integer that's less than or equal to negative 1.3 is negative 2. Now take a moment and sketch the graph of what the greatest integer function looks like. Pause the video and do that. Okay, so everywhere between 0 and 1, we're going to get that the greatest integer of those values is actually 0. So the greatest integer less than or equal to 0 is 0. And then everything up until 1 is going to be 0. But I'm going to have a hole right here. And as soon as x equals 1, then the greatest integer less than or equal to 1 is 1. And all of the values for x between 1 and 2 will equal 1. And then as soon as I get up to 2, it bounces up here to 2. And so it kind of looks like stairs. 2, 3, everything between 3 and 4, everything between 4 and 5, etc. And then that goes on forever. And then that same pattern follows down here. So everything between 0 and negative 1 is actually negative 1. So I've got a hole right here, and then the step, and then a hole right here, and then the step.
You need to get your stuff like right now.
Sylvie,
Well, I have to.
I am recording. Okay, etc. Okay, and that's the end of the video, just in time.